Hi, this is Nimla Rednam. In this video, we are going to solve the sums from exercise 8.1 along with the try these questions and solved examples for the same. In the previous video, we looked at the concept, the theory part of it. This is the 8th chapter, which is algebraic expressions and identities, right? So let's get into the sums. Let's look at the first example given. They have given three algebraic expressions and they want us to add these three expressions. We have discussed how to add, subtract or multiply any two or more given algebraic expressions, right? So here, like I said, for adding, what we need to do is we need to write the expressions with the like terms in the same column. So that means that here I have, for example, I have an xy here, right? And then I have an xy in the third expression over here, right? And that is the reason why he has written these two in one column. Similarly, if you look at yz here, I have a yz in the second expression, right? That's why these two are in one column, right? This is how you're going to align them with all the like terms in one column, in a single column, so that you can simplify them. So now after writing them, that is the first step. Now we are going to simplify it. So here if you see 7xy minus 2xy. So simply you solve the coefficient 7 minus 2 will give you 5 and then you will write xy, right? So this is how we are going to be doing the addition and subtraction problems. Now here I have a subtraction. So what is the difference is, now in subtraction the order matters. So I have to subtract this expression from this. So clearly this is what I'm going to write first. So after writing it, identify the like terms and respective places you're going to write the like terms in the same column. So 5x square will come below 7x square, minus 4y square will come below plus 8y square, and so on, right? Now, after this step of aligning all the like terms, what we are going to do is you are going to reverse the signs of the second, all the terms in the second expression, right? Why? Because it's a multiplication, because it's a subtraction, right? So, if here I have plus y, 5x square, so I'm going to write minus 4y square will become plus 4y square, plus 6y will become minus 6y, and minus 3 will become plus 3. Now, so 7 minus 5 is 2, minus 4, here there's no term, so as it is. 8 plus 4 is 12, so I have 12 and so on. So this is how we are going to do subtraction. So it's the same as addition, only additional step is you have to reverse the signs of all the terms in the second expression, right? That is when you have two expressions in the subtraction. So now let's look at exercise 8.1. So now I have the first question is about adding. Let's quickly do these sums. So I have exercise 8.1. The first question, first bit, I have three expressions here. So what I'm going to do is first expression I'll write as it is, AB minus BC, right? And then if you look at the second expression, I have BC minus CA. So you can see that BC is similar to this. It's a like term with this. So I'm going to write it below that. And after BC, I have minus CA. This is a different term. So I'm going to write it in a different column. Now let's look at the third expressions. We have three expressions here. The third expression is CA minus AB. So CA, clearly I'm going to write it here. Put a plus sign so that there's no confusion, right? And then I have minus BA, right? The third expression I have minus AB, right? So I'll write it below BA plus AB, right? So now I'm supposed to add. Take one column at a time. This will give you 0. This is also a 0 and this is also 0. So that means the answer is 0, right? That is our first sum. Let's look at the second sum. A minus B plus AB. First expression I'll write as it is, and then I have to worry about the like terms starting from the second expression. Now the second expression is B minus C plus BC. B I have to write here, right? And minus C plus BC. There is no BC term here. So again, another new column. Okay. Next, I have the third expression is C minus A plus AC, right? So C is again, I'll write it here, C minus A. So you can see that I have a A here. So I'll write it here. And then I have plus AC. I'm going to add this. This column A minus A will give me 0. Minus B plus B will give me 0. I have an AB here. I have a 0 here and a BC and a AC. So my answer is AB plus BC plus CA. After solving it, usually whatever be the order of the terms, we will finally write it in the standard form, which is simply, you're taking all the three variables ABC in cyclic, AB, BC and CA. That's just a convention. Next, let's look at the third question. 2p square q square minus 3pq plus 4. I have only two expressions here, right? So the first expression, let me write it here. 2p square q square minus 3pq plus 4, right? The second expression is 5 plus 7pq minus 3p square q square. So I have 5, which is the constant term, right? And I have 7pq, so I'm going to write it below this. And then I have minus 3p square q square, right? So these are the like terms and this will give me plus 4pq plus 9. So this is my answer, right? So this is the third sum. Next I have 4 expressions. Okay, 4 expressions are given to us. Let me write them down quickly. I have L square plus M square, right? And then the second one is M square plus N square, right? And the third one is N square plus N square. I have an L square here, so I'm going to write it here. And there is a fourth expression which is 2LM plus 2MN plus 2NL. Okay, absolutely no like term compared to the first three expressions. So this is going to give me 2L square plus 2M square plus 2N square plus 2LM plus 2MN plus 2NL, right? So this you can simply write, you can take a 2 common or you can leave it there as well, no issues. So this will be our final answer, right? So this is about the first sum. So as you can see, adding any number of given algebraic expressions is as simple as first you're going to write the expressions one below the other, making sure that the like terms are in the same column. If there's no like term, you will form a new column, right? And then you're going to simplify it by looking at the coefficients. And then you're going to finally write it in the standard form, which is usually you'll get an understanding of it once you do more problems, right? So this is how we are going to do adding algebraic expressions. Next sum, we are going to look at subtracting. Okay, so how do you subtract? In subtraction, they'll give two expressions, right? So you will be given an expression which has to be subtracted from another expression. So this second expression is what we will write first, and then you will write the first expression that is given to you. So usually whenever you're doing adding or subtracting, whatever is the first row, the expression that you are going to write first, you can write it in the order that has been given to you. We can worry about the like terms and aligning them in the same column from the second expression onwards. So here if you look at this, the first expression is 12a minus 9ab plus 5b minus 3, right? Because I'm supposed to subtract 4a minus 7ab plus 3b plus 12 from this. So first I'll write this in the order that they have given, okay, without changing anything over there. So I have 12a minus 9ab plus 5b minus 3, right? So next, when I'm writing the second expression, I have to look at the like term. So I have a 4a which comes below 12a, right? And then I have minus 7ab which will come here. So it's given in the same order, looks like it, 3b and 12. So plus 3b and I have a plus 12, right? Okay. Now this is a subtraction. So one additional step that we are going to do is I am going to reverse the signs of all the terms in the second expression. So I'm going to write a minus here. I have a plus here, minus and a minus here. So 12 minus 4 will give me 8. Minus 9 plus 7 will give me minus 2. 5 minus 3 will give me 2. Minus 3 minus 12 will give me minus 50. So this is my final answer, right? So why are we changing the signs? It is like this. If I have to subtract 2, for example, if they say subtract 2 from 7, what are we going to do? 7 minus 2, right? Which is nothing but 7 plus minus 2. Correct? That means I am going to write the additive inverse of this and then add them as we know the addition. That is one way of trying to understand why we are reversing the signs. Next question. Let me write this expression 5xy minus 2yz minus 2zx plus 10xyz as it is in the same order that is given to us. 5xy minus 2yz minus 2zx plus 10xyz. Now from this I am asked to subtract 3xy plus 5yz minus 7zx, right? So 3xy, I am going to write it below this. 5yz will come below this and minus 7zx, right? So again, like earlier, I'm going to reverse the signs and then add them up. I'll get 2xy minus 7yz plus 5zx because 7 minus 2 is 5. And this I'm going to bring it down as it is. So this is my answer for the second question, second bit. And then I have in the third bit, I'm going to write the second expression first. 18 minus 3p minus 11q plus 5pq minus 2pq square plus 5p square q, right? So this is what is given to us. And now I'm going to write the second expression by carefully aligning these terms given. 4p square q. Okay. Now where do I write 4p square q? It's a p square q term. So I have to write it below this. I'm going to write it as plus 4p square q. Second term in my first expression is minus 3pq. Be very careful with the signs. Here it's a plus and here it's a minus. Okay. Minus 3pq. After that I have plus 5pq square. This is 5pq square. And then I have 8 minus 8p. So it will come below minus 3p. After that it's 7q plus 7q. And then finally minus 10, right? So this is the expression that I'm going to subtract. Now here, first I'm going to change the signs, right? So I have 28 plus 5p minus 18q plus 8pq minus 7pq square plus p square q, right? So this is the final answer. Now you can write it in the standard form as in the higher degree terms first. So if I do that, I have p square cube minus 7 pq square. You can leave it here as well. This is also correct. Minus 7, and then I have pq term here plus 8 pq, and then plus 5p minus 18q plus 28. Usually the constant term comes in the last in the standard notation. So you can rearrange the terms and write it like this, because you know that it's commutative. You can write 2 plus 3 as 3 plus 2 as well, right? So I'm going to rearrange it and write in the standard form. So this is about the first exercise, where we have looked at how to add any two or more given algebraic expressions, and also how to subtract any two given algebraic expressions. In the next video, we'll look at exercise 8.2.